Anybody who's done any kind of technical stuff knows that stuff fails, stuff breaks.
Yeah.
And if you have spent any amount of time with me, you know that I have a computer virus in my kidney that kills any and all electronics. So it is just, par for the course. All right, so we'll go about 30 more seconds. And thank you all for everyone who has joined. This is really exciting to be our kickoff.
I know I can see your chats, Christine. I'm not sure if I can see other people's. I have the Q&A open.
And I believe the chat may be disabled. I'll see if I can update that. All right. All right, so I think we'll get going here. Thank you guys, everyone who has joined. This is the first inaugural kickoff of the US National Astronomy Education Coordinators Present series. We plan on hosting a series of free webinars for educators to just gain access to some really neat data-driven astronomy lessons that you can immediately implement in your classes. The US-NAEC team, as it's known as, is deployed for 4 years at a time by the Office of Astronomy Education, which is housed within the International Astronomical Union. There are currently over 400 representatives from 83 different countries. And in the US, we are really involved in trying to just spread the word, collect information about what teachers are doing, and be able to equip and assess what the national landscape is in terms of astronomy education. And I know we have a lot of people joining from all over the world, which is really, really neat. And we plan on hosting these every month, bringing you a different resource every single month. Tonight, I'm really excited that our very first kickoff is using cosmic data stories. I specifically wanted this to be our very first one because I have heard Dr. Patricia speak a couple of times. And when I was at the American Astronomical Union, I'm sorry, the AAS session back in January, she presented on this, and it was so neat and immediately implementable into a class and data driven. And I just thought every educator needed to hear about this. So when I knew we were going to be doing this series of webinars, I knew they had to be first. So with that, thank you very much for you guys joining. And I have really quick a couple of icebreaker questions for John and Patricia. What is a country that you have always wanted to go to and why?
Yeah. I guess for me, so I know it would be Scotland.
Ooh.
That's because I'm a big fan of archaeology, and for the pandemic, I got into a British TV show called just forgot its name. It's a British archaeology TV show that does digs all over England, and I just got really interested in. It's such a beautiful country with such a deep history and a deep past that, yeah, it just sort of fascinates me. And,
Nice.
yeah.
I would love to go to Egypt, in particular for the solar eclipse that is going to have like 7 minutes of totality. And I forget what year it is, about 2027 or yeah, I think it's 2027.
Yeah.
Awesome. All right. I'm going to turn it over to you guys. And if participants, if you can see there is a Q&A at the bottom, feel free to drop your questions in there. And we will have time at the end for you guys to be able to ask your questions. Take it away.
All right. Well, thank you so much for inviting us to speak here and for your kind words about our work. We're excited to share what we're doing. We have a very brand new activity that we're excited for you guys to be the first to see on the planetary alignment as requested by Christine. So Cosmic Data Stories is part of NASA's Science Activation Program, which is geared towards helping NASA subject matter experts, so scientists, engineers, share out their work with the public. And so our project is one of about 30 or 40 projects that we all kind of collectively work together. And our project in particular, we're building online resources for helping people develop data skills and understanding of how to learn from data. So I'm the science PI for this project. I got my PhD in astronomy. I realized that my passions lie more towards teaching than doing research. So I became a high school physics, astronomy, and math teacher for about 5 years. And then after that, I came to the CFA, where I'm part of the science education department, and we develop curricular resources for astronomy education. John, do you want to say a few words?
Yeah, so I'm John Lewis. I'm a software and curriculum developer and educator with Cosmic Data Stories. Like Pat, I also did my PhD in astrophysics here at Harvard. And during my first postdoc, I quickly realized that I much prefer teaching. And I did a great deal of teaching as a graduate student. I think I TA'd something like 8 times and TA'd and taught summer courses many times. And I found I spent a lot more time teaching and working on things related to education than I did in actual science. And so I found this position, and it was sort of everything that I wanted in a job. And so it was kind of perfect. And so, yeah, so I work a lot on building these stories along with another developer, John Carriffio, and we sort of work on trying to figure out how do we take large and complex data sets and fit them into frameworks that are easily accessible for teachers, for students, and things like that. And so we sort of take the data and the science literacy skills that we've learned as PhDs and people who work with large data sets and sort of leverage that into creating these stories. And so, yeah.
Awesome. Okay. So just to give you a brief outline of what we're going to discuss today, we'll give you a quick introduction on the Cosmic Data Stories project itself. We are very excited to share our Planet Parade data story. And then we have a few other data stories that we just wanted to highlight that we thought might be of interest to this particular audience. One thing that I wanted to ask, Christine, is there a way that we can drop in links to all of these stories that
yes, you should be able to. And I also just enabled, okay, so I've changed the settings in the chat, so everyone should be able to drop in something to the chat, so they will drop in links. Maybe if everyone wants to put in where you're from.
Yeah.
Awesome, thank you. Okay, so we have a pretty big team, but most people are part-time, but these are all of our people. I'm not going to say a lot now. I think since we got a little bit of a late start, we want to just kind of get underway. Online, easy to access tools. Your students can use the data stories to collect, visualize, analyze authentic data from NASA missions using the same tools that scientists use. We want them to answer some significant question in our longer stories. For example, how do we know how old the universe is? We have an air quality data story where we want them to think about what's in the air they breathe. And then we know that learners will be more engaged if they feel like the content is relevant to them. So we try to situate the data explorations within some relevant context. We have a pretty broad audience base. So we have a variety of stories to suit different situations. So we have a long kind of in-depth lab data story on Hubble's law that is suitable for Astro 101 or high school astronomy classes. We're working on some shorter kind of one class period activities. So our air quality activities will be of this sort of 45-minute type. Our Eclipse data story has an educator guide that can be done in a class period. And then we just have a bunch of shorter kind of lifelong learner experiences, or some teachers we've heard use these as like a do now. At the beginning of class, you can give your students a link and just let them explore the data story, and then they can share something that they took away from it. So the tools that are baked into the cosmic data stories include Worldwide Telescope, which is an astronomy visualization tool that lets you get access to data across the whole sky, across multiple wavelengths. You can situate like pretty images from the NASA missions, like in context in the sky. So it's not just a pretty picture, but you know where in the sky it is and what is happening contextually around that image. And then our longer data stories include another software tool called Glue, which lets you explore multi-dimensional data using these linked views. So basically you have a data set that you have a scatter plot, you have a histogram, you have a map, and you want to know, okay, what is, like, why is there this binary distribution here? So I can highlight this group, and then those same data points light up in all of our other views. So you can get a sense of, is there something happening spatially that would make this different than this? So Glue doesn't get used in all of our stories. It's used in our longer stories. Okay, so the Planet Parade. I think everybody's heard that there is a grand planetary alignment coming up at the end of this month. And Christine had mentioned that it would be cool if Worldwide Telescope could be used to help visualize this. Oops, I didn't mean to do that. All right, so this link, John, can you drop this link in?
Yeah.
And what this will do for you, the default location is Cambridge, Massachusetts, because that's where we are, but you can change your location. So say if you want to see what this would look like from Texas, I'll go to Texas, and it defaults to the current time. We're thinking about changing that to be about 4 p.m., which is a little bit before sunset for most people. And then you can just watch this happen. And so you've got Venus, Neptune, Saturn, Mercury, and the Sun have already gone below the horizon. And you can turn on the ecliptic. So the ecliptic is the path that the sun appears to move around the sky on. And pretty much the planets also lie on this same path. If their orbits are a little bit tilted, then they'll be a little bit above or below the ecliptic line. But if you just follow the ecliptic, you can see, so Mercury, Saturn, Neptune, Venus, Uranus, Jupiter, Mars. And what this helps you find out is which way should I go look in order to go see this. So if you're in the northern hemisphere, you'll see all of these kind of setting sort of towards the west, and you would want to be looking south in order to find the rest of the planets. We'll kind of zoom out a little bit to see this in better detail. And we have some explanatory text to kind of help you understand what is happening. How do I go find it? What is the significance of this? Like the news is kind of making a big deal about this. And it's basically a coincidence that all of the planets are on one side of the sun during this period. So we have a video that if you click this, it will show the same video, but I put it in here. I'm not sure if it makes a difference. So this is just an overhead view of the solar system. You can see where the Earth and the sun are. And then these are all of the planets that we've marked kind of with bigger images. And anything that's on this side of this line, you'll be able to see after the sun goes down. So you can just see that all of those planets, I'm going to drag this back so I can talk. Oops, pause. Yeah, so all of the planets just happen to be on this side of the line during this time period. And the planets, even though people talk about the parade, are not actually marching in a line. They're kind of all over the place. But because we're all in this plane, then when you look along the plane, everything seems to be moving in a circle. John, is there anything that you wanted to share in particular about this?
I was going to say one of the really great things, this gives you a sense of how far separated they are. So you can set your location and your time to when you're out, to when you're outside at night, and sort of get an idea of where everything is for yourself. The constellation stars don't show up particularly brightly, and so constellations can be brought up to help orient you. So if you know Orion, you can kind of tell what's near Orion and then move from there, right? And so like Jupiter is right above Orion, Mars is on the other side of Orion from Jupiter. And so it's really useful for one, sort of like simulating this and like simulating in the classroom, trying to ask your students, where are the planets? How do they move in the night sky from day to day? And then also just for going out and trying to do your own sort of observing and spotting, seeing how many of the planets you can spot. So yeah, you have full control over the time. So you can see even if you can even look and investigate for yourself. Are there other planetary arrangements? I know Pat noticed one, I think sometime in April, just by sort of going forward. And so it's interesting to see that the sky is really a very dynamic place. And especially if you live in a city, you just sort of see the stars in a sort of this very still image. But this gives you the clear impression that things change and move from day to day. And so it's sort of a really good, that's the arrangement that we saw. So it's a really good way to sort of break some of the conceptions that we can have of a very static universe and a very static sky. Yeah. And we're also always, if you have suggestions or things you say, oh, this would be a really cool thing to see in this or something like that, we also very much want to hear from you guys, like what you guys want to see, what interests you guys, and we can see what we can add, see what can be done, and talk with you guys. But yeah.
Awesome. Yes, so there was one other thing that I noticed after we built this and we were testing it and I was playing around with it. I never really fully appreciated how you can understand that Mercury and Venus are like interior to the Earth's orbit just by watching how they move in the sky on a day-to-day basis. So right now, let's see, this is the 11th. Mercury is almost like on top of the sun. And as you move forward by days, you can see Mercury kind of moving away from the sun. And eventually it starts to come back. Oh, I think that was a daylight savings time change. And then it starts coming back towards the sun. And then it's going around, like you can tell that it's going around the other side. And then it's going to start coming back again if I make it a little bit earlier in the day. Yeah, so the other planets are all kind of going by, but now Mercury's coming back. And Venus does the same thing, but kind of on a further apart timescale from the sun. And, that's one of those things where like I kind of learned about this phenomenon in a textbook and I didn't really understand what it meant. But getting to just play with this visualization really kind of hits home like, oh, okay, like Mercury is going around the sun and you can actually see it.
Yeah. Oh, that is really cool.
All right. Are there any questions or ideas about the planet parade?
Yeah, one suggestion, like tying them to the lecture tutorials about planets, which are those lecture tutorials. I assume these are the lecture tutorials from Arizona.
Yes,
are really cool.
Yeah, that's a great suggestion.
Yeah,
and that's one of the things that I kind of didn't struggle with, but we realized we built this because there's interest around this particular event coming up. But I think as Jimmy is suggesting, that this is just a generally useful tool for understanding how the planets move in the sky. And I think it will have longevity beyond the planet parade, but maybe we'll need to rebrand it after the planet parade passes us by.
And I think what's so interesting about this, and the reason I really wanted to incorporate this now is your students are going to be able to access information. The information lives on the internet, but it doesn't necessarily mean that it's correct. And I think it's so important to be able to provide students with data where they can see like, okay, they actually are always in a very similar plane. They're only about 5 degrees off. This doesn't necessarily correlate to the end of the world or disasters, and it's actually not even that rare. And being able to equip students with the skills and the data to differentiate, poor information from more accurate information, especially in today's day. And there's nothing out there that does that. So I thought this was just such a great tool to be able to present students with, just with this data and this visualization to be able to see why we see what we see.
That's great. Thank you, Christine. So another feature that we thought about adding, and we might still do it, but we're not completely sure that it will be helpful, is to give the option to switch over to the 3D view where you could kind of look down from overhead and imagine where everything is. The problem is that the scale is challenging. And so if you go to worldwidetelescope.org, this is the program that is running behind the scenes in all of our data stories. But what we've done is we've just basically changed the interface and only kind of picked certain features that we want students to be able to use in order to kind of prevent the overwhelm from like all of these gazillion buttons and options. But okay, so if we go to the solar system mode, this is basically the view that I took for this video. It's this same worldwide telescope view. But it's hard to see, like even if you scale up the planets to be as large as possible, it's still kind of hard to tell where everything is, which is why I took a screenshot and then overlaid my own larger planets on top of it. But if you think that it would be useful to let your students toggle between these modes anyway, even though this is not as crystal clear, that's something that we can think about doing. So if you have thoughts on that, let us know. All right. Let me get back to my other slides. All right. Okay. Um, John, do you want to talk about the solar eclipse?
Yeah. So this was we can go to it here. Can you put the link in the chat? And then
I can't seem
so
to
you can,
copy and paste out of the.
all right, I can do it.
I can do it though. You talk. I'll type.
All right. So this is our solar eclipse data story. They made this for the grand, I don't forget what the branding was, what the Grand American Total Eclipse back in April. And the idea was to sort of create an app for helping people plan where they're going to, where the best places to observe were. And so we leveraged NASA's MODIS cloud cover data set to cloud cover data set to sort of provide predictions on what areas are going to have cloud cover, right? And to allow students and basically like the entire public to figure out when was the eclipse going to occur for them, what areas nearby would be clear, what was the likelihood of good or bad weather, and sort of think about how do you make how do you use data to make good decisions. And then there's sort of the scientific goals of asking, why is there a solar eclipse? What's happening, right? And so this gives sort of an explanation of where that comes from, as well as giving you a view from on the sky of what the sun and moon are actually doing from your particular location. And so we know that a solar eclipse is caused by the moon going between the earth and the sun, and it blocks out some or part of the light from the sun, kind of like this image, but not quite to scale. And so if you show the main window, yeah. So this allows you to play the time and move and scrub the time forward and backwards to see what time will the eclipse occur for you. Or depending on where you are. And so you can do this from somewhere either in the eclipse path or away from the eclipse path, to get an idea of like what exactly you'll be able to see. We also try to include a lot of stuff in that sort of the buzzwords are place-based, where you can see things from whatever your location is. And so this will technically work if you're in Africa, right? It'll try to show you what you'll see, but there's no eclipse there, right? And everything is below the horizon at that time. But basically, you can the idea is to see what's going on from wherever you are in the world. And so we're making one for the 2026 eclipse, which is far less accessible location-wise than this last one, it's sort of going across the coast of Iceland and across Spain. And I guess Greenland, if you live in Greenland. And so it is, again, where are the best places to observe? And we can in principle make this for the one in 2027 in Egypt, one in 2028 in Australia. And so the idea is using these to just teach students, what's going on with the solar eclipse, what's the sun, what's the relationship between the earth, the moon, the sun, those orbits. And then just also a little bit of how does the earth change with time, and like just understanding weather and climate patterns near you. One of the things we had in the 2024 data set story was views of what the historical weather looked like. So you could see how rainy is it usually on the day of the eclipse, how cloudy, right? So that you can get a sense of how patterns and climate changes across time. And so it's, yeah. And so, yeah, so I think, so yeah, it's pretty fun. This itself got used by over 11,000 people on the day of the solar eclipse.
And then about as many not on the day of the eclipse.
Yeah, and about as many not on. Yeah. And so, yeah, so you can see, right, we're showing like how does the cloud cover vary, right? So if you're in Bismarck, we're in Bismarck, Montana, and we're hoping for a clear day, then you probably were out of luck. We had also a bunch of day of features for seeing what the weather prediction was, the actual forecast, things that since we're past it, we've cut off using it, but you can still see things like when was the eclipse, right? And how long was it where you are, right? And why is it so long? And so it's very useful for just a lot of these are geared towards investigating questions and thinking about how things are changing and how the universe works. And this one we also had an educator guide that we wrote for it that sort of provided a guided or a jumping off point for teachers to investigate the solar eclipse with their students and give them context. And so you can see that here. And so as the teacher, you get, when we produce them, you can get more detailed information and sort of a scaffolded approach to using these data stories, because they're designed ultimately to be educational tools and not simply visualizations. But like most people realize, really good science and data science communication involves using really useful data visualization. So yeah. And so there'll be more on the 2026 eclipse and other ones at some point in the future. But yeah, we have a lot of things that we're working on. And did you have anything else you wanted to say?
No, I think you pretty much covered it. Are there any questions from the attendees on or ideas on using the eclipse data stories in your classrooms?
I see a couple of hands up. Do you guys have questions?
Oh. Yeah, we're happy to take questions. David.
And that might have been an accident. Okay, maybe it was. Yeah. Denise, do you have a question?
I see that you have a lot on here regarding solar eclipses. Do you have anything regarding lunar? Because that is a typical problem in a K-12 environment, is having students being able to tell the difference between a lunar and solar. Just a question on that. Thank you.
Yeah, that's a good question. So we have not made lunar eclipse apps, but that's something that we could think about doing. Okay. And one of the things that, we're able to do with the solar eclipse visualization is, kind of put up the corona image at the right time. So I think we would need to think about how to visualize, the moon going red and, kind of how the shadow comes across. I feel like the visualization is a little bit more complicated to like render in an accurate way. Yeah. But John, do you have other thoughts on that?
So yeah, I think it would be a really cool visual. I think it's one that lends itself to the 3D view, where you can sort of see top down why the shadow is coming across. Or also something guided where you show that the sun is on the exact opposite side of the sky from the moon. But yeah, I think that's a really cool idea, and something that would be really great to explore. But yeah, I think the 3D view, or it would be something that would really benefit from having, like comparing the 2D and the 3D view to give people a sense of what's really going on.
Yeah, and we do have an older project for Worldwide Telescope called Think Space, where we do have a moon phases curriculum, and there is a small chunk on eclipses for that. So that's
Does that also cover the tides? Because that's another concept that I have to teach in my standards coming up is the tides. Thanks.
we haven't linked this to tides, and we could. So we'll add that to our list. If you teach seasons, there's also a seasons activity, which we are planning to update to use more of these modern visualizations that we're using in the data stories. So, you can see where the sun rises and sets from any location using this tool. Back when we built our seasons curriculum, we were tied to using the Worldwide Telescope desktop version, and we had to be in one location. So it kind of only really works for Boston, but it gives you an idea of how the seasons change for everybody. But so our plan is to update that using this type of framework so that you can see how the sun rises and sets from anywhere.
Another question I have for you is this Planet Parade is like a really great resource for us to use in our classrooms. My only question is for my students that may not have a telescope, and we want them outside looking up because that's definitely an accomplishment to get them out there. What planets, can you review with us again, what planets you would see with the naked eye versus what you need a telescope to see with?
Yes.
The chances are my kids will just have their eyes and maybe a set of binoculars. I have a couple that may have a telescope. Thanks.
Yes, great question. So from most reasonably dark places, so I mean, like not in like New York City or some very bright place, you should definitely be able to see Venus. And that's kind of what we recommend as the starting point, because Venus is so bright that it's pretty easy to spot. And then let me get this a little closer to sunset.
And it really shows you that it's rather surprisingly high, right? We often think of it as the evening star, the morning star, something that's up just when it's kind of dusk out and you still sort of have a slightly blue sky, but it's up rather late because it gets rather far from the sun on the sky.
Yep. Yeah, so Venus is the brightest, start there. And then you would basically look almost straight down. And it depends a little bit on where you are. Like you can kind of put in your location to see what the angle is. But here in Brownwood, Texas, Saturn is almost directly below Venus, like halfway between Venus and the horizon. And then you kind of follow this path, and we're not going to see Uranus by eye. Sorry, Uranus. And then you should be able to see Jupiter. Jupiter is pretty big and bright. And then if you keep going, you should also be able to see Mars. And Mars should be distinctly redder than the other planets. So those are the four that you should be able to see from most reasonably clear, dark places. Another kind of benefit here is you can see where the moon is. And the moon's coming up, so the moon will make it a little bit harder to see everything. So if you want to pick a time when the moon is down, I guess maybe is that going to be, hold on, which way is the moon going? So the moon go this way, or hold on. Okay, yeah. So the moon actually is going in the helpful direction because the following day it's further and further down. So it's not kind of getting in your way of seeing all the planets. There was another question. What was your other question? John, do you remember the other question?
Sorry, I don't.
Telescopes, not having telescopes. So we have collaborators at the Center for Astrophysics at Harvard who have a program called Observing with NASA using the Micro Observatory. And these are little robotic telescopes. We have one on the roof of the Center for Astrophysics in Cambridge. There's a couple in Arizona, and there's one in Chile. So we have Southern Hemisphere coverage. So if your students want, they can put in a request for observations for whatever object they want that is in the night sky for the time range that they're talking about. And there's tools for Micro Observatory for them to decide what filters they want to use. And then they can use a JS9. What would you call that? It's just a image processing software where you can combine your red, green, and blue filter images. And it's a really popular activity. Students like to kind of get in there and process their own images.
We had a question in the chat from Jimmy, who was wondering if the data stories use any of the data science frameworks, like Jimmy, I don't know how to say it, GUIS 2, for example. I asked if that was like research or theoretical.
Yeah. So Jimmy, you were at, I think, our ASP presentation, and you were the person who told us about that framework. And it has been very helpful. We are making use of different concepts, and I think a lot of the things we were kind of doing already, but to kind of have it be standardized and like what should we be calling this thing that we're helping students learn how to do. And so we're kind of looking there right now for our assessment questions for evaluating our Hubble data story. We're making use of that content. So we're very glad you told us about it.
Yeah.
Other questions?
There's another question in the Q&A saying like, I think it's Syed, are these tools, for example, Cosmic DS, Worldwide Telescope, for demonstration purpose only, or can you use them to make assessments, homework for entry-level course? And I would say
that's a good question. So I would say not just demonstration, but the students get to go to this page and do the exploration. Whether you can use it for creating assessments, I think that would kind of be up to you and how you would set that up. Like you might write something that is similar to our guided exploration for the solar eclipse. And if your students could have the data story open on their computer, and then they could write down their responses, that would be great with us. We do have one of these longer data stories on the Hubble law that is, it's very structured and curricular, and there are questions that are embedded throughout for students to kind of reflect on what they're doing and learning. And for these, there's an educator dashboard where you can kind of monitor where in the story all of your students are. So if you have kids who are kind of falling a little bit behind, you can go and tap them on the shoulder. Do you need any help? And you do see how they're answering all of the multiple choice questions and the free response reflection questions. What's a good stage for demonstrating some of this stuff? Maybe if we go to like stage 4, 5.
Stage five has the most like questions and stuff.
Yeah. Okay. Well, so just a quick overview of what we're doing here. So we're using data from the Sloan Digital Sky Survey. So students can make their own measurements of velocities for galaxies using the spectra. And let's see. Okay, so you have the spectrum data for the galaxy. There's a little tutorial that teaches you about spectra if you're not already familiar with it. And then you have, you can show where the rest wavelength of a certain line is. This is H alpha, and this is where the observed wavelength is. And I can go in and measure that. So this is at a wavelength of 6812 angstroms. And then there's a little tool that helps you turn this into a velocity using the Doppler formula. And you go through and you get velocities for all of your galaxies. And then you can measure distances by assuming that your galaxies, because they're spiral, and we know we're a spiral galaxy, we make this kind of naive assumption, but more helpful than you would expect. But it's not letting me go. Oh, there it is. Okay. And so I can measure the angular size of this galaxy and see that it's 43 arc seconds in the sky. If I do this distance formula and plug in, do my unit conversions, then I get a distance to this galaxy. So we have each student do this for 5 galaxies, and then you get to graph it and make a Hubble diagram. So we're graphing velocity versus distance. Do I see a trend? I'm not so sure. I can't tell. So then we bring in their classes data so that there's, if you have 20 students in your class, you now have 100 data points. So you get a better idea of whether there's a trend because you have more data. And then we fit a line to this and get an age. And then we can compare the age measurements for everybody in the class. So somebody in this class got 8 gigayears for the age of the universe. Somebody got 9, 10. Where's me? This is me. I got 17 gigayears. Somebody got 27. So, given the naive way that we measured these distances, our team was actually really surprised by how within the right ballpark these all seem to be. And so then we're asking students to think about, all right, we don't really know what a scientist who's measuring something for the first time doesn't know what the right value is. So how do you figure out what confidence you have in your measured value? So we line up all of their classmates' measurements in this distribution. They can look at the mean, median, mode. And I'm just using this to skip around. And then we can talk about confidence. So this is the inner 50% range. This is the inner 68%. We don't talk about, sigmas, but if you have students who have more advanced statistical skills, you can certainly tie this to that. And then we can have them look at the data. So these are all of the students in the database. And then we've combined all of the students in a class into one measurement. So all of these are the class by class measurements for the age of the universe. And so you get a sense of, okay, is it better to use 100 galaxies to measure the age of the universe, or is it better to use 5 galaxies to measure the age of the universe? I started talking about this because you asked about tests and quizzes. And did I blow by all the questions? Okay, so we're comparing these, which spans a larger range of ages. So students have to answer these questions. If they get them wrong, so they lose points. Well, if you answer it correctly the first time, you get 10 points. And then you get some deduction for every number of wrong answers until then. And so I don't know if that's helpful, and that was a very long-winded answer to probably a straightforward question. And but now we've shown you the Hubble law. And we are recruiting educators to participate in a summative assessment of this data story. So if you would be willing to have your students use this in your classroom this spring and give them an assessment before and after they do it, so we can measure what they learn from doing this activity. We actually, there's a sign up. I think I actually put this on the slides. Okay. And I know we're hitting close to the top of the hour, so I should probably stop there.
If you can get me a link for that, I will send that out in the follow-up.
Yes.
That's awesome. Do we have any other quick questions before we do a quick wrap up?
Citizen science projects. That's a good question, Denise. Not at the moment, but the NASA Science Activation Program is going to be doing a call for new proposals this spring. And one of the possible extensions of what we're doing if we get funded for the next round is to collaborate with the Galaxy Zoo, the Zooniverse team, who are doing citizen science. So not yet, but it's been a request. So a lot of the students say, you know, this Hubble thing is really cool, but it would be even cooler if the measurements I was making were to be applied to some actual science research and not just be like a classroom exercise. So we're thinking about ways to make that a thing.
Cool. So in a follow-up, I will send out the link for that to everyone. This has been so great. I'm so grateful to have you guys here in our inaugural kickoff, and for being able to pull together something on the planetary parade and debuting it here. That's just spectacular. And I just love this ability to be able to bring in this data and to really bring the macro into our classes is such a powerful tool for students and truly allows astronomy to be this gateway to scientific literacy. Real quick, we have 2 announcements from the NAEC team that will take about 30 seconds. I'm going to replace your share. The NAEC team is, and William, I have allowed you to share here if you would like to. William from our team is hosting an astronomical essay contest. Can you guys see the QR code?
Yes.
Perfect. And so here's the QR code. I can also send that out afterwards. William, do you want to say anything about this?
Yes, this is in support of attaining scientific literacy among our students, and it's pitched for the high school students. It's a contest with prizes, and the genres of writing are not just essays, but they could be research reports, and they could also be poems or speculative fiction. We're trying to be as inclusive as possible. And if you go to the website, which is a little long, if you just went to the Galactic Inquirer, that would get you there. Um, but the deadline is March 15, so you basically have a month.
Cool.
And we've gotten interest from around the world, but of course the kids are probably working on their submissions till the last minute, so we don't have that many submissions. So I encourage you to get more submissions in.
Excellent. Thank you very much. Lastly, if you would like to join our listserv, this QR code will take you to a form and we can send you out information about when we have our next webinars, all of the information from this one. I promise not to fill your inbox too much, and you can follow us on LinkedIn and Facebook. It is printed just like that, U.S. National Astronomy Education Coordinator team, and you can join us on March 11th, where we will be hosting Rubin, the Vera Rubin Observatory, and their investigations. Thank you guys very much. Thank you, John and Pat, for joining tonight, and thank you, everyone. And we look forward to seeing you again next month. Thank you.
Thanks so much for having us. This was really fun.
Thank you very much. Thank you guys for all of your work. This is phenomenal. Thank you, everyone.